Hi, and welcome to the second of 4 videos for the review for Math 126 exam number 1. In video 1 we looked at questions 1 through 5, now we'll look at questions 6 through 10. Question number 6, again, is a factoring problem. We want to factor 3x squared minus 4x minus 7. So you have a couple ways you can do this. You can do trial and error. You could do by grouping, so you break the middle terms apart. Whichever method you want to do is fine, as long as you get the binomial at the end that this quadratic factors into. So I'm going to do it as the trial and error method. So 3x squared has to break up into 3x and x. It's like, what factors do I have of this? It's 1 and 3. What factors do I have for 7? 1 and 7. So then I need a combination of those. It's going to give me minus 4. So that's if I put the 7 here, and if I put a 1 here. And I need the middle term to be negative, so I'm going to put the negative with the 7 and the plus with the 1. That's it, but if factoring is not your strong suit, I would recommend FOIL this. When you get an answer for a factoring problem and you think you're done, but you're not really sure, or maybe you don't feel that great at doing factoring, just FOIL it and check. So I'm saying, okay, here's my answer on the test, but let me see. 3x times x, 3x squared. Outside, 3x times 1 is plus 3x. Inside, negative 7 times x, so minus 7x. Negative 7 times 1 is minus 7. So this is 3x squared minus 4x minus 7, which is what we started with. So I am 100% sure now that what I factored it into, what I have in the box, is in fact, 2 binomials that when multiplied together give me that quadratic. All right, number 7. So we want to simplify the following. We have x plus 7 over x minus 7 minus x plus 14 over x all over x minus 7 minus x plus 7 over x. So there's a couple ways we can go about this. There's 2 methods basically. Find the LCD of the numerator, combine them, find the LCD of the denominator, combine them, and then keep, change, flip, and cancel any similar factors that we have. The other way I like to do it, which is by find the LCD of all 4 terms, and then multiply every term by that LCD, and that way it gets rid of the fractions for us, so I don't have to deal with them anymore. Whichever method you use, as long as it simplifies into the same answer, that's all we really care about. So my LCD for this guy would be what? Well, I have an x minus 7, and an x, and an x, and an x minus 7. So my LCD would be x times x minus 7. So if I multiply every term by x times x minus 7, x times x minus 7, x times x minus 7, x times x minus 7. The other thing I would caution here is we've got negative signs all over the place. And this is the biggest area where people are going to make what we call the dumb mistakes, right? You mess up a sign, and as soon as you mess up a sign, this whole problem is going to go sideways on you. So this next step, take a few extra seconds, make sure that you're accounting for all the negative signs as they should be. So let's look at this first term. Well, this x minus 7 cancels with that one. So what am I left with? X times x plus 7. So that's the first piece. Minus. And you can see I'm using parentheses. I would highly suggest doing the same. This piece minus this piece. This piece minus that piece. Then you can distribute your negative signs so you don't get into that trap of not distributing it somewhere. So what do we have here? This x cancels with that one, so I get x plus 14 times x minus 7. In the denominator, this x minus 7 cancels with that one, so I get x times x minus what? This x cancels with that one, so I get x plus 7 times x minus 7. So now I can start simplifying a little bit. So this one I have an x, I'm going to distribute it to both pieces. So the first one I get x squared plus 7x. And from that, I'm subtracting, I have to FOIL this thing. So I get x times x is x squared, x times negative 7 minus 7x, 14 times x, so plus 14x, and 14 times negative 7 is minus 98. So this one here, negative 7x plus 14x is just plus 7x. So what goes in here is x squared plus 7x minus 98. That's what I have in the numerator. In the denominator, I have x times x is x squared minus, and this is what? This is a difference of squares. So the middle terms are going to cancel out, and when I FOIL this, I get x squared minus 49. So now, if I come up here, now I can distribute this negative sign. So I get what? I get x squared plus 7x minus x squared minus 7x minus a negative 98 is plus 98. All over x squared minus x squared minus a negative 49, so that's plus 49. So now cancel out. So this x squared cancels with that one. 7x minus 7x, so I'm just left with 98 in the numerator. And then x squared minus x squared, they cancel out. I'm left with 49. 98 divided by 49 is 2. So this giant mess simplifies into 2. So no matter what x I pick, as long as it's not 7, because this would be undefined, or 0, because that would be undefined, but any other value I pick for x, when I simplify this whole thing, it's going to end up being equal to 2. That was number 7. Number 8, we want to solve the equation. We're given square root of 5 minus x plus 1 equals x minus 2. So I'm solving a radical equation. So that means what to me once I think I'm done with this problem? It means I have to check my answer. Radical equations or rational equations, equations that have fractions in them, if I get an answer, I must go back and check my answer to see if it's actually a legitimate answer, or if it's going to make a radical negative, or if it's going to make a denominator 0. I have to check for all those things. So with this kind of problem, what's the first thing we have to do? Well, we want to get the radical pieces on one side, numbers on and variables on the other. So I'm going to subtract 1 from both sides, so I get square root of 5 minus x equals x minus 3. Now my next step is to what? It's to square both sides. So when I square the left, the square takes out the radical, so I just get 5 minus x. And what do I get on the right side? Think about it for a second. Tell yourself in your head, say it out loud. It's what? It's x squared minus 6x plus 9. So please do not just distribute the square to both of these pieces and say it's x squared minus 9. That's not what it is. This piece is really x minus 3 times x minus 3. So if you need to write it side by side and FOIL it, fine. But don't forget this middle piece. So let's get everything on the right, 0 on the left. So I want a minus 5 here and plus x. So minus 5 and plus x. So I get 0 on the left. Then I get x squared minus 5x plus 4 is 0. And then I can solve in a couple different ways. Try to factor it and use zero property rule, completing the square quadratic formula. This one will factor nicely for us into x minus 4 and x minus 1. So if I separate this, x minus 4 is 0, x minus 1 is 0. So x equals 4 and x equals 1. But as I said, we are not done. Do not circle both those answers and move on to number 9. We still have to check whether or not these answers are valid. And when we check these answers, always go back to the original equation. That way, if you made a mistake somewhere along the way here, it doesn't compound itself. If you check it in the original, if it works, great. If it doesn't, we know we have an issue. So let's check x equals 4. When I plug that in, I get what? Square root of 5 minus 4 plus 1. And I want to know, is this equal to x, which is 4, minus 2? This is square root of 1 plus 1. Is this equal to 4 minus 2 is 2? Yes, 1 plus 1 is 2. So I know that x equals 4 is a valid answer. How about x minus 1? When I plug that in, x equals 1. I get square root of 5 minus 1 plus 1. Is this equal to 1 minus 2? Well, you might be able to see already we have an issue on this side with the negative. But if I simplify, I get what? 5 minus 1 is 4. Plus 1, is this equal to negative 1? So square root of 4 is 2, plus 1 does not equal negative 1. So x equals 1 is not valid. So my only answer for this equation would be x equals 4. Any other number, not going to work. So number 9, and again I'm going to erase this, so if you need it, go ahead and hit pause. As I mentioned in video 1, if you're not in my class so you don't have this review sheet and you still want to use this for a review, that's fine. Just see what problem I put up, hit pause, try to work it, hit play, see if you got the right answer. So 9 is another solving an equation. This time we have y to the third minus y squared minus 4y plus 4 is equal to 0. So I need to factor this one in order to solve for y. Well, I have 4 terms, so that's my red flag to factor it how? Factor by grouping, or at least make that attempt. So with these first 2, what can I factor out? Only a y squared. When I do that, what am I left with? Y minus 1. So I know if I'm going to do factor by grouping, I basically want a y minus 1 over here. So what do I have to factor out of these 2 to get y minus 1? Well, it's if I factor out a negative 1. And now by grouping, I take out this y minus 1, and I get what? I take out a 4. Take out a minus 4, that leaves me with y minus 1. So take out y minus 1, I get y squared minus 4 equals 0. So then the question is, can I factor this one at all? And the answer is yes, because this factors into what? It's a difference of squares, y plus 2, y minus 2, all times my y minus 1. So now I can use zero property on all 3 of these. Y minus 1 is 0, y plus 2 is 0, y minus 2 is 0, so y is 1, y is negative 2, and y is positive 2. So I have 3 answers for this one. I started with the cube root, So that's sort of a heads up to me that I should have 3 answers unless I get some duplicates. In this case, there was no duplicates. There's 3 individual answers for what values of y would make this equation true. And then lastly, for this video, number 10, I want to solve 2x squared plus x minus 3 is 0. So, can I factor this one? Well, we can try. So I need 2, and then I have a 3 here, so if I put my 3 in a 1, oh yeah, we'll factor, won't it? Okay, so we can factor this one. We can actually factor this one and solve it. Yeah. That'd be minus, this would be plus. So this one we can just factor into 2. If this wouldn't have factored, and I apologize, let me check my notes here. Oh, yeah, okay, I did have this. So I thought this was a quadratic formula. If it didn't factor, we could have used quadratic formula. But in this case, it does. Yeah, I guess there's no quadratic formulas on this one. But if it didn't factor, we could have used quadratic formula. But because it does, I can use zero property rule. So 2x minus 3 is 0. X plus 1 is 0. So add 3. 2x is equal to 3, divide by 2, x is equal to 3 halves. So over here, x equals negative 1. So for number 10, we get 2 specific answers. X is 3 halves, x is negative 1. We were able to solve it just by factoring and using zero property rule. If it doesn't factor nicely for you, you're always able to use the quadratic formula. So that's it. That's the end of video 2. Come on back and we'll look at problems 11 through 15.